Non-Euclidean Geometry by Roberto Bonola. Chapter 1. The Attempts to Prove Euclid's Parallel Postulate. Section 4. The Greek Geometers and the Parallel Postulate. Further evidence of the discussion and research among the Greeks regarding Euclid's postulate is given by the following paradoxical argument. Relying upon it, according to Proclus, some held that it had been shown that two straight lines, which are cut by a third, do not meet one another, even when the sum of the interior angles on the same side is less than two right angles. Let AC be a transversal of the two straight lines AB and CD, and let E be the middle point of AC, figure 3. On the same side AC, on which the sum of the two internal angles is less than two right angles, take the segments AF and CG upon AB and CD, each equal to AE. The two lines AB and CD cannot meet between the points AF and CG, since in any triangle each side is less than the sum of the other two. The points F and G are then joined, and the same process is repeated starting from the line FG. The segments FK and GL are now taken on AB and CD, each equal to half of FG. The two lines AB and CD are not able to meet between the points FK and GL. Since this operation can be repeated indefinitely, it is inferred that the two lines AB and CD will never meet. The fallacy in this argument is contained in the use of infinity, since the segments AF, FK could tend to zero, while their sum might remain finite. The author of this paradox has made use of the principle by means of which Zeno, 495 to 435 BC, maintained that it could be proved that Achilles would never overtake the tortoise, though he were to travel with double its velocity. This is pointed out under another form by Proclus, pages 369 to 370, where he says that this argument proves that the point of intersection of the lines could not be reached, to determine, by this process. It does not prove that such a point does not exist. Proclus remarks further that since the sum of the two angles of a triangle is less than two right angles, Euclid, Book 1, Proposition 17, there exist some lines intersected by a third that meet on that side on which the sum of the interior angles is less than two right angles. Thus, if it is asserted that for every difference between this sum and two right angles, the lines do not meet, it can be replied that for greater differences, the lines intersect. But if there exists a point of section for certain points of lines, conforming with a third interior angles on the same side, whose sum is less than two right angles, it remains to be shown that this is the case for all pairs of lines, since it might be argued that there could be a certain deficiency from two right angles for which the lines, would not intersect, while on the other hand all the lines for which the deficiency was greater would intersect. Proclus, page 371. From the sequel, it will appear that the question which Proclus here suggests can be answered in the affirmative only in the case when the segment AC of the transversal remains unaltered, while the lines rotate about the points A and C and cause the difference from two right angles to vary. Non-Euclidean Geometry, a critical and historical study of its development. This book was written by Roberto Bonola, professor in the University of Pavia. It was published by the Open Court Publishing Company, Chicago, 1912, and is now in the public domain. Read by Jim Renholt, with programming and illustrations by Jim Renholt, 2019. Thank you for listening.